Hi, this video is a part of a wide series of videos that I'm creating. In these series of videos, what I'm trying to achieve is to answer why certain formulas of math are what they are, or the rules that people think are mathematical rules, why are they even rules? So you're trying to get to the why of things, not just trying to memorize formulae or rules, but to understand where they are coming from so that we can build a deeper understanding of quant. So in this video, let's try to understand this, that why is even under root always positive? So I'll stick to square root, but the basic understanding is applicable to all even roots. So what I'm trying to say here is, let's say if x squared is 36 versus x is root 36. In this case, x can be plus minus 6. But in this case, x can be only 6. X cannot be minus 6. This causes a lot of confusion to a lot of people because in their minds, this and this mean the same. So why do we have different things there? That in this case, x can be plus or minus 6, but in this case, x can be only 6. And then some who are a little mathematical savvy, they also reason out that, well, why can't I write like this, that x is equal to root 36? So root 36 can be written as minus 6 into minus 6. No, minus minus will cancel out. So eventually I'll get 36. So I can write it like this. And under root is basically half power. So this is power 1 by 2. So that is minus 6 raised to power 2 into 1 by 2. So that gives us minus 6. So they're arguing that, well, we can mathematically derive that x can be minus 6. So why are we saying that x can be only 6 and not minus 6? Well, the answer is simply that this is by convention. What do I mean by conventions? Conventions are accepted things which naturally cannot be proven. If something can be proven, then this is a proven thing, right? It's a convention means mathematicians have taken it to be the case that we'll always treat, let's say, an even root as always positive. So it's a convention. There are more such conventions in math. There are a lot of conventions in math. So it's a convention. It is not something that can be mathematically derived, that even root or square root has to be positive. On the contrary, as I have shown here, one can mathematically argue that a square root can eventually uh, turn out to give a negative answer, right? But we have taken to be a convention that will always treat them to be positive. So even though one can mathematically argue that negative is possible, but in math, we always treat even roots, square roots, always positive. Okay, this is by convention. This is something that mathematicians have decided to take it like this. Now, if you are curious, you may want to ask, but why did they make this convention? This doesn't make sense, right? Then I may say that, well, convention is a convention. We don't really question conventions. And you may settle down or you may think, oh, well, he doesn't have an answer. But I'll not go down that path. There, of course, if a lot of sensible people are coming together and saying that, okay, we follow this rule or we take it to be the case, then there must be some reason, right? So all conventions have some reasons. Now the reasons can be very, very strong, or the reasons may not be very strong, but essentially there is always a reason for taking certain things to be a conventions, right? So what is the reason here for taking this to be a convention? So I'll give you one reason. There are more complex reasons for taking even roots to be always positive as a convention, but I'll give you a simplified reason, which is also one of the reasons. So let's say there is a distance formula, right? I'm just taking an example. There are a lot of situations in math in which we just want to talk about the positive or the negative entity. For example, let's say I'm talking about coordinate geometry and the distance between 2 points. How do we calculate that distance? X2 minus x1 square, y2 minus y1 square. This is how we calculate distance form, right? Distance. So we just write this distance equal to this. Now let's talk about a world where we don't have convention, without the above convention. So what does that mean? In this world, we don't have that convention that even root is always positive. So even root can be negative also. Now in this case, in this world, this can give you a negative number also, right? But distance can only be positive. Then I can't write like this because this can give me something negative, but distance is always positive. Then how do I write the formula for distance? I want to make sure that I have something positive. One thing is that I can put it in a modulus, right? This is something that I can do. So if you want to talk about only positives, then I'll always need to enclose these even roots within modulus, right? Now let's say I want to talk about just negative. There could be situations in math, right, in which let's say I'm talking about a mirror image of some coordinate or something. Or there could be other situations also in which I just want to talk about the negative entity. But if I just write square root of something, let's say just write square root of 300. Now, in this world where we don't have the convention that it is always positive, this can be positive or negative. But I want to just talk about the negative entity coming out here. How do I talk about that? If I want to talk about positive, then, well, I can talk about positive by putting a modulus here, right? But if I just want to talk about negative, what do I do? Think about it. You may pause the video and think about how do you talk about only the negative. Well, you talk about only the negative by first making sure it's positive and then putting a negative here. This is how you make sure that the entity is always negative. In this world where we don't have this convention that it is definitely positive, so it can be positive or negative. If I just want to talk about positive, I put a modulus here. If I just want to talk about negative, I put a negative and the modulus. So you can see that in this world where we don't have the convention, it is really cumbersome to talk about just positive or just negative. It is very easy to talk about both at the same time. We can just write under root 300. But if we just want to talk about positive or negative, it is really cumbersome. You have to put a mod, and in case of negative, you have to negative mod, right? Whereas with the convention, if you want to talk about positive, you just write under root 300. That's it, right? Because in this convention, under root square root is always taken to be positive. So you just write like this. In case of negative, you just write like this. So modulus is completely gone from the picture, right? You don't need to constantly bring in modulus. If you want to talk about both, then this is just this, right? So with this convention that even root is taken to be positive, sort of writing certain expressions becomes much simpler, much less cumbersome. Okay, so that is one reason, one simple reason why mathematicians have chosen this to be the convention. Okay, there are more complex reasons around functions and all that. I'm not getting into those. But essentially, this is a convention that has been taken, and there is a reason for taking that to be the convention. Okay, I'll just take you a step further to also sort of talk about a common complexity that this convention leads to, and a lot of people get completely confused in that. The complexity is that, let's say if I'm given under root x square, what is this equal to? A lot of people think, well, under root x square means x. Well, x is a variable. Do you know it is positive or negative? Some people look at x and think, well, x is positive. No, no, x is a variable, right? It can be equal to some negative number also, right? And let's say if x turns out to be something negative, then in we are violating the convention that the square root is giving you equal to something negative, right? So this is not correct. If you have under root square root of x square, you always write it like mod of x. So this is how things are written to make sure that the convention is followed, right? Because the convention is this is always positive, but we don't know whether x is positive or negative because it's a variable, right? So in case of a variable, we put a mod. In case of a number, we don't need to put a mod because we know 8 is positive. Okay, so because of the same convention, in case of numbers, things are simplified. We get rid of the mod. But in case of variables in which we don't know the sign of the variable, then we have to put a mod. So things become a little complicated there. And that is the reason. So convention is the reason we write square root of x square as mod x and not just x. Okay. I hope this helps. If you have any questions regarding any part of the video, anything is not clear, please feel free to ask. And if you have any ideas in mind, any questions in mind, why certain basic mathematical formula work, or you want me to create a why video on any other specific math topic, please share that in the comments. Thank you.